So, children, how are you? Today, we are continuing with the application of resistance. In the previous class, you have studied what is a resistance, what is a resistor, then what are the factors on which a resistance depends on, and the device to vary resistance. Continuing with the device used for resistance, we are looking back the case of a rheostat. So we told you that the rheostat is used to vary resistance in a circuit. It is true. Just remember about the Ohm's law experimental verification, where we were changing or adding the batteries turn by turn to change the voltage. So here, what is the significance of rheostat in a circuit? Once again, we can discuss. The significance of rheostat in a circuit is that without changing the voltage source, we can change the current in the circuit by working a rheostat, because rheostat is used to vary the resistance. There are three factors with you: V, I, and R. So naturally, when V is kept constant, when we try to change R, I automatically changes. So the thing is that what is the significance of rheostat? For a constant voltage source, we can derive different values of current by changing the values in the rheostat. So coming back to the applications of resistance. So we use so many resistors, electrical wires, and we use so many gadgets where alloys are there. So let us take some specific examples. The first example is the case of aluminium and copper, where aluminium and copper are used for making conducting wires. Copper is used for making conductive wires in household circuit, and aluminium is used by our power supply, electricity board, like that. So why they are used? Because aluminium and copper are having less resistance and they are ductile too. And as they are having less resistance, they can conduct, they are good conductors of electricity. So a 1-mark question or a visualization question can be asked based on this concept, where aluminium and copper are used for making conducting wires. Why? Because they have less resistance or less resistivity, and they are good conductors of electricity. Next, we go for the concept of alloys. So, some alloys are used for making heating devices. We know nichrome is an alloy that is used in our iron box. So, why? It is getting heated, right? And it is having a high melting point also. So, we are coming to a question. Alloys are used for making heating devices. Why? That's the question or a concept given in your textbook. Why alloys are used for making heating devices? Because they have high resistivity and they do not oxidize at higher temperatures. These are the 2 points that you write. So what is the first point? Alloys, they have high resistivity and they do not oxidize. Even though oxygen is there, they do not burn to ash. They do not oxidize at higher temperatures. So these are the 2 points that you have to write when a question is asked. Alloys are used for making heating devices. Now we will look the example of tungsten. We know that we have tungsten bulb, right? And tungsten is having high melting point and all the other characteristics of tungsten that we will discuss in the heating effect of electric current. And another alloy, it is an alloy of tin and lead that is used in safety fuses. That also it is having a low melting point. So these are the resistors or the current conducting devices which can offer resistance so that their specific property is used in some applications of electricity. Thank you, children.